Welcome to comparing two population means. So the idea here is we have two populations. And we wish to compare the averages for some variable. So wish to compare their averages for some variable. So we have our two populations. So we have our population 1 and our population 2. And we would take a mean of both. So the mean of population 1 would be mu1. Mean of population 2 would be mu2. So the goal is to compare mu1 and mu2. So to do this, we take a sample from each population. And then we take the sample mean from both and we compare the sample means. And then we use the sample results to try to make judgments about the population means. So when we use inference, all right, to generalize to the populations. Okay. I'll be back. All right. So we're specifically going to study when we compare x1 bar and x2 bar, we're going to study the difference. So when we compare these, we'll look at x1 bar minus x2 bar as our way to compare. Study how far apart these two sample means are. So when we study the distribution of the difference of sample means, we are going to have two samples to consider. So we'll have sample 1 and sample 2. From those, we will have a sample size N1 and a sample size N2. We will have a sample mean x1 bar and x2 bar. And then we will have sample standard deviations S1 and S2. So we will have all of these things to consider. And then we also will just have for our populations, one and population 2. We will have a population mean mu1 and population mean mu2. And then we will have a population standard deviation sigma 1 and a population standard deviation sigma 2. So these are all of the symbols that we are going to be considering. Again, we are looking at the difference in sample means. So we are studying x1 bar minus x2 bar. So first thing we have is the shape.
The snake goes.
So turns out that the shape of this distribution is normal if, and then either both populations are normally distributed or both samples are size 30 or larger. So again, we have option 1, which has both sets of population data.
Oh, look what you found.
Are normally distributed. Or option 2,
Frog
both samples
and snake. Frog
are
and
size 30 or larger.
snake.
So these are exactly the same justifications that we needed for a normal distribution for the X-bar distribution. It's just now we need it for both samples or both populations instead of just for the one we're involved with. For the center, the mean or mu sub x1 bar minus x2 bar. So the mean of this difference of the mean sample means distribution is simply equal to the population mean for population 1 minus the population mean for population 2. For our spread, for our standard deviation or standard error, this is sigma sub x1 bar minus x2 bar. This is equal to the square root of S1 squared over N1 plus S2 squared over N2. So this is actually this first part is actually the standard error of the X1 bar distribution. So this is the recall that the X1 bar X bar distribution, we would just do this.
Yes.
So that's just that standard deviation squared. And then we can do the same here. This is technically, again, a standard deviation of the X bar distribution. We do the standard deviation divided by the square root. Oh, I apologize. If we know the standard deviations, these should actually be sigmas for now. So if we actually knew the standard deviation, it should be sigma 1 squared and sigma 2 squared. Again, technically this should be sigma 1 squared and sigma 2 squared. Right. And then we can approximate this just like we did for the t distribution previously. So we can approximate with the square root of S1 squared over N1 plus S2 squared over N2. But then this would require us to use the t distribution. So we'll do x sub x1 bar minus x2 bar is equal to this approximation. And then this would require the t distribution.
Oh my goodness, they're standing up. They're standing up. Standing right up.
So this is just sort of the basics of the distribution of the difference in sample means. We will do most of these calculations just letting Desmos do all the work, but this is technically what's going on in the background.